We're now going to move on to our next big data structure. The next big data structure that we're going to discuss are stacks. So in this section, we're going to take a look at some diagrams around stacks, understand what they are, and then we'll get started on a written implementation of a stack. In general, you can think of a stack as being extraordinarily similar to a queue. There's just a couple items here and there that are slightly different. So with a stack, we're still dealing with an ordered list of records. And you can imagine that those records are living inside of some container, which is the actual stack. Adding a record to an existing stack is referred to as pushing. So we might say that we are pushing a new record onto a stack. When it's time to remove a record or take it out of the stack, we would refer to that as popping, or popping a record from the stack. Now the big difference between a stack and a queue are the order in which items are added and removed. So with a queue, we had that acronym FIFO, or first in, first out. With a stack, we deal with FILO, or first in, last out. To look at this in diagram format, you can imagine here the big white box is our stack. So if we first push in record A to our stack, so this arrow here is saying we are going to push record A into our stack, we would then have record A inside the stack. If we then pushed in B, B would be conceptually sitting on top of record A. So then the first time that we popped a record or removed a record out of the stack, it would always be B, because the first in item is the last one out. Record A here was the first one in, and so it's going to be the last one out. Another way of thinking about it that might make a little bit more sense is to say the last record in is the first record out. So B was the last one in, and so it's the last one to come out on the other side. Again, you should really think of a stack as being very similar to a queue. We're just making a small change here as far as the ordering of records are being removed from this data structure. So in implementation, this ends up being very much similar. Like the code we're going to write to implement a stack will look very, very much the same. Before we flip on over to our code editor and start on our implementation, I want to focus on the three methods that we're going to implement to create a stack. So just like we discussed, adding a new record to the stack is referred to by saying that we are pushing a record. So we would make a push method on our data structure that would take a record and add it to our stack. To pop a method, or excuse me, to pop a record, we would create a pop method. And the idea there is that we are removing an item from the top of the stack. Now notice that I put in here quotes for top because in code there really is no top or bottom to the stack. These are more kind of conceptual items that we keep in mind. Finally, we can optionally implement a peek method, which would return just the top record without actually removing it or popping it off the stack. So these are the three big methods that we want to think about. So without further ado, because this data structure is so similar to a queue, I think that we'll kick off the implementation in this section. No need to split out to a separate section. Inside my code editor, I'm going to find the stack directory and open up the index.js file. And then of course, I will also start up my tests by running the command jest stack/test.js --watch. And we should see about 4 tests passing here. Very good. Okay, so the directions here are pretty straightforward. We're going to write methods push, pop, and peek. Now keep in mind that we also need to have some type of record keeping structure inside of this class, the stack class, to actually hold on to and order our records. So remember, in the JavaScript world, whenever we implement some of these basic data structures, we sometimes use an array to actually implement the underlying data structure that contains our data. So I kind of expect that you're also going to end up implementing a constructor method on this class as well, and initializing an array and assigning it to something like this.data. In general, I really recommend you go back and look at the code from our queue example because it's going to be very, very similar to that queue class. There will just be 1 or 2 little terms that end up changing. Okay, so go ahead, take a shot. I'll catch you in the next section and we'll start to look at some solutions.